Okay, we'll start. Good morning. Thanks for being with us here today. So today we'll discuss about PostgreSQL version upgrades, and we'll discuss about different types of approaches that we have to upgrade our databases in PostgreSQL. So choosing which approach to choose for the production. So before going to that, let me introduce about myself. I'm a PostgreSQL DBA, working with Percona for last 4 years. I have around 8 years of experience in handling PostgreSQL databases. So moving further, so the today's agenda is about why we upgrade PostgreSQL in general. We'll discuss about that, and then we'll move on to the versioning policy that PostgreSQL follows, and then we'll see what are the different types of upgrades, and then there are normally two types of upgrades in PostgreSQL, which is minor version upgrades and major version upgrades that we do. So in major version upgrades, again, there are different approaches that people follows to do it, and we'll discuss upon which one is better and how do we do that. So later on, we'll quickly compare those upgrade mechanisms, and then we'll decide on how to choose a right path for production. So coming to this slide, like why upgrade PostgreSQL? In general, there are many reasons to consider for upgrading a PostgreSQL. I'll say these are the main four major reasons where we need to consider to upgrade PostgreSQL. So we want our databases to be protected. We want our databases to be secured. So in order to do that, we need to have the security fixes applied to our databases in whenever the community releases the minor versions or major versions. So PostgreSQL in general releases minor versions for every 3 months, and major versions once in a year. So yeah. So apart from that, so one more reason that we need to consider is like bug fixes. So every software has bugs. So for a software which is evolving so fast like Postgres, it is common to have bugs, and community addresses them very often with major versions. So with every major version, we have these bugs fixed. So that's the one more reason that we consider it. And the other reasons like performance improvements and new features. These performance improvements and new features generally comes with major versions. So like once in a year. So that is one more good reason to consider to upgrade PostgreSQL to our newer versions. And the last version, community support, but not the least. So for each version that PostgreSQL supports is for a set time. So after that set time is over, then you are on your own. So they won't release bug fixes or security fixes to that particular software. So you have to go for a end of life support from external vendor like us, maybe Percona, different vendor in the market, so which will cost you more. So instead of doing that, it's always better to follow the roadmap, release more roadmap, and plan ahead of what is being deprecated and what version is being deprecated and what version is supported. So it helps us to keep databases safe. So before discussing about the upgrade types, I would like to you guys to check out this tool, because so once we decide on getting upgrade to get our databases upgraded, so the first and foremost thing is like to check the release notes and see what all has been deprecated and what all has been added. So it is always tough, like if you're jumping from one like less version to like let's say from 14 here to 18, so there are like you are skipping almost 4 versions here. So you have to see what all has been compatible or incompatible with your applications and stuff, right? So this DSP's tool will help us to identify what all has been done between those 2 versions. It gives a clear picture of what all has been changed, and is your application is compatible with it or not. So that kind of information you can get from this. So here I've entered 14, and then I'm moving to 18.3, right? So it gives me around 4.4 years worth of changes and fixes, and then so instead of going manually and checking PostgreSQL community page and figuring out on your own, it is like good tool to check it out. So normally it is not recommended because if you want to like major version, you can skip it, but always check the release notes, what has been deprecated and stuff. But it is always advisable to be on latest minor version of that particular version and then go to a different version. Yeah. So we'll discuss about the PostgreSQL versioning policy here. It simply follows two number scheme, which is like, sorry, two numbered scheme. So here it is like PostgreSQL 18.3, right? 18 is being the major version, and the 3 after dot is called minor version of that particular major version. And then, so as I said earlier, minor version releases for every quarter, like for every 3 months, you get a minor version releases addressing bugs and security fixes majorly. There won't be any new features or improvements on that particular minor version. It's simply security and bug fixes. So on major version, once in a year, normally releases around September or October. So instead, we also have a release mode roadmap in PostgreSQL official documentation page wherein you can plan ahead, like when what is getting released, and then you can decide on upgrading the PostgreSQL. So the upgrade types coming to the within the PostgreSQL are majorly two types: minor version upgrade and then major version upgrade. So coming to the minor version upgrades, we can say these are kind of a maintenance activities that we do. So primarily addresses big bug fixes and security fixes. So there won't be any compatibility issues with minor version releases actually. So you can upgrade it as per your availability and downtime requirements. So it needs very minimal downtime. You just need to download the latest minor version binaries on your database server and then restart the database with latest binaries. So that's it. So normally community feels not upgrading to the latest minor version is very riskier than upgrading it, because you have to restart and you think like not it is not worth restarting a database at this point in time. So it is not advisable. So it is always better to have to be on the latest minor version of that particular major version that you guys are using in your applications. So how to do it? You just check the release notes to see what all has been released as a part of that particular minor version, and then you download the latest binaries of that particular minor version, and then you restart it. That's it. The upgrade is complete. So coming to the main part, the major version upgrades. So these are considered as like projects, we can say. The minor version upgrades are kind of maintenance activities. So these, so for doing this major version upgrades, there is a plan. You need a lot of planning and testing and validation. So because there are a lot of behavioral changes with each major version release. So normally it requires moving from one major version to the other major version, like in this case, like 14 to 16 or 17 or 18. So so this involves compatibility and behavioral changes. Your application may break if something has been changed as a part of that release. So you have to test it on your staging first, run your application functionally on it to see what all has been changed or what all syntaxes has been changed or some the way that use it has been changed, and then decide on that particular part. So it offers new performance improvements and capabilities as a part of this new release. So coming to the upgrade methods, in PostgreSQL, we'll typically have 4 methods to upgrade your database from one major version to other major version, like PG dump all, PG dump, logical replication, and then PG upgrade. We can say first 3, the PG dump all, and then logical replication operate at logical layer of database. So and the PG upgrade will be at the disk level, files level, binary level. So these are the 4 major approaches, 4 approaches that we follow. We'll discuss them in detail of each approach. So this one, the PG dump all. So it creates a logical text format of your entire database cluster. So like it includes all the databases in your database cluster. It takes a dump out of it, and then it restores it on to a newer version that you have installed it already on the same server or different server. So you can use pipe symbol to restore your database and stuff. But so what happens is like it works well with small databases. The command is very simple. You write a pg dump command and then you dump the data out of it. It takes care of globals, table spaces, and everything. So once you start this dumping of database, that's where your downtime starts. So it depends upon size of your database. And number of database that it needs to be dumped. So and it is a single process job. You can't parallelize it. So the downtime grows linearly with the size of the database. So which is not advisable. So and some of the advantages could be the upgradation process is simple. It's a simple commands, and then so once you have this dumping of data and restoring it onto a new server, you eliminate bloat. You don't have fragmentation, so that you can eliminate it by using this approach. And then yeah, restores time grows linearly with the database size. It is as advisable to do it if you have the downtime that could be allowable according to it, the application needs. So and then the other approach is like major version upgrade using PG dump. So this is another utility that comes as a part of PostgreSQL. So what it happens is like in case of PG dump all, it is like entire cluster you are dumping it, right? So like let's say if you want to upgrade only a single database and you have the downtime, the required downtime. So what you can do is like you dump a single database out of PostgreSQL cluster and restore it into a new versioned cluster. So here you can use the parallelism. So you can dump multiple tables by using number of processes that are available on your server. So that is one thing that you can do, and it also eliminates the bloat since it only dumps the active data out of PostgreSQL tables. And it supports plain custom and directory formats wherein the backup size that you are doing could gradually reduce compared to the PG dump all, because that's a plain text format. Here you can use multiple formats with this. And it depends upon PG dump all in the first because it has to dump the globals. PG dump can't dump the global roles and table spaces and stuff. So you have to dependent it on PG dump all to have that information first, and then restore that globals first, and then you do PG dump of database that you need. So this is suitable when so you have allowed downtime, which is by the how much time the PG dump takes. If you have that much of downtime allowable in your SLA and application level, so you can use it. It is pretty simple. But if you want to dump a lot of databases out of a big sized cluster, then that's where the downtime starts, and then it is not suitable. So next thing is like PG upgrade. This is kind of a tool which is very famous in PostgreSQL to upgrade the databases. So it takes very minimal time. It operates at a binary level, so not at a logical level. So fast it does the in-place upgrades where you don't have to take dump of at logical layer. It uses it does the in-place upgrades at disk files level. So it ensures catalog compatibility between different versions. So and so it does the upgrade of in-place data files, and it takes very minimal downtime compared to the PG dump and PG dumpal, because it is not dumping data and then restoring it. It is just changing it in place. And then you can't do the partial upgrades with this. It's entire database cluster you can do it. You can't dump a single database by using PG upgrade. So that is not possible in this case. And then it is only designed for major version upgrades, not minor version upgrades. So with PG upgrade, you have three different modes. One is copy mode, link mode, and clone mode. So coming to this copy mode, what it does is like it physically copies each and every data file from one location to the one database cluster location to the another database cluster location. So what happens is like it is kind of a time consuming process, and with this switch particularly, and it requires 2x disk space. Like let's say if your database is like 4 GB, you need 4 GB of another like extra space to dump your data and restore it onto a newer versions data cluster. So with comparing among the three modes that PG upgrade offers, like copy, clone, and link, this copy method is somewhat slow, but it is very safe since you have a set of the old set of files and new set of files. So if you want, in case you want to roll back to the old version, it's available there and then and there. Then you can. That's a easy rollback setup. So that is the copy mode. We'll see about link mode. So link mode comes into picture where the downtime, you can't tolerate downtime and you want to have your database upgraded very fast. So instead of copying files, what this link mode does is like it creates an hard links between the old files and new files. So what happens is like the data block will be the same, but the hard links are created between old cluster and new cluster. So the both links will refer the same data block. So if something changes in the new cluster, you can't roll back to the old cluster. So that is one drawback with this approach, but it is very fast since it's just creating hard links. So it is very suitable when the downtime is very extremely low window. You have very extreme low window of downtime, then it is very helpful. So once you start the new cluster, you can't go back. So you have to have a rollback well defined. Like let's say you should be having at least one backup or one extra standby, which is ready in case of your you need rollback or something. So normally, generally people use link mode more in production to avoid downtime, extra downtime. See, other one is like clone method. So with PG upgrade clone method, you got both the advantage of copy and link. So it has been introduced into PG upgrade as well from 14 version, I believe. But it is supported on specific file systems only, like XFS, Btrfs, and AFS. So what it does is like it creates a copy and write file system. So ref links it creates normally. So what happens is like you have a copy like structure where you have old data files and new data files referencing the different files. But when you start the cluster, if you write something, it only appends that to our new data files. It won't disturb the old data files. So the rollback is easy. And you logically independent. These two data clusters are logically independent. So that's how you get the balance of both link and copy method. So we can use clone method as well to perform the upgrades. So if you want to have that rollback strategy inbuilt into it. Yeah. So it's not copy is default. Yeah. So if you use -link approach, you could take advantage of rsync and upgrade your standbys as well. So you don't have to again build standbys by using PG based backup or from any PG backrest setup. You can do the linking approach, rsyncing approach to eliminate the rebuilding of standbys. So your high availability is also in place. And there is one more approach to, apart from this binary approach and PG dump and PG dump all, there is one more approach called logical replication. So that is this is helpful in case if you want to have zero downtime, near zero downtime upgrade. It's not completely a zero downtime upgrade. It's just like kind of building a new separate environment while your active environment, your active PG is open for application. So, but setting up of logical replication is a bit difficult because it has to copy all the data. But there are some approaches where you can eliminate the initial copy by using some methods like PG dump and PG restore, like freezing an LSN and creating slot and then dumping the data. That is doable, but sometimes what happens is like let's say if you want to go with the default approach with the logical replications, like you have TBs of data, since it creates a snapshot. So whatever the data that has been created after that snapshot will have some issues, like you may face some wraparound issues because of the data not being copied in time and stuff. So you have to take care of that thing. So in order to do that, you have to make sure you copy the initial snapshot of data with some other approaches. So that is one thing. So logical replications in the sense like it replicates the data between different versions. So and it has some pre-work setup needs to be done, like all tables must have primary keys, and then sequences are not replicated, so you have to take care while doing the cutover. And then yeah, the if you can't offer primary key or unique innes in your table, you have to set replication identity to it, wherein it generates lot of val data. So it will be tough to synchronize that much of data between old and new cluster by a single process, because the wall decoder is a single process. So there is there might be a lag of that. So the advantages of this approach is like it enables you the near zero downtime. The old and the new clusters can run simultaneously. So that is one approach. Once you are okay doing switch over, then you can do it to the new version. So considering all the things that we have said. So quick comparison. So of the approaches that we have, and what is the risk and complexity of it. So like let's say if you have PG dump and restore, so it is dependent on size as we discussed, and it needs 2x disk space because it has to dump and restore the data. So and the complexity is very low. It is simple command, and risk is also very low. But you have to but the downtime is dependent on size, so you can't like do something on that. And with the PG upgrade copy, it is also size dependent because it copies each and every file. So and you need 2x disk space. And the complexity is very medium because you have both the clusters, and then so and risk is very low. So with the PG upgrade hyphen link, usually it completes less than 5 to 10 minutes, mostly even under 2 minutes as well if you plan it way ahead. So it's not size dependent. It depends upon the number of files, like number of objects that you have in your database clusters, because it has to create the hard links to it, right? So that is one thing. So you need very low resources for it, but it is very high risk. Like let's say if something goes wrong in the middle, you should be always have a rollback strategy, because if you like let's say after completing creating hard links, you start your new cluster, you can't go back to your old cluster. So that's why we recommend to have a replica or a standby in place of old version, and then do it. So with the clone, it offers same like link approach only, but you have two independent clusters. So I think clone would be the best option if you have downtime, maybe less than 5 or 10 minutes if you can offer downtime. So and you have the supported file system, like the file systems that I have mentioned earlier, then the clone would be the best option. So then logical replication, so it needs resources more, and initial setup will also be high, and the risk is also a medium kind of thing, but you can achieve near zero downtime with this.
I know that the clone option is available in all versions.
Yeah,
So could you tell me which version?
I think it's available from 14, I believe.
14?
Yeah, PostgreSQL 14. Yeah. Okay.
Last time I learned this upgrade, I upgrade to 30.
13. Okay.
So
Yes. Okay.
that's
Yeah. So I think it has been introduced in 14, I believe. Yeah. So which one to choose, like right path for upgrade? It always depends upon the downtime that you have and the approach that you use and the resources that you have to upgrade it. Like so is about especially downtime tolerance and database size. So I believe PG upgrade fits most of the cases if you allow if you have 5 minutes or less downtime. So if you want near zero downtime, it's like logical replication is the approach that you have to choose. So regardless of this, you have to have testing and validation prior to planning major version upgrade, which is a very important thing. Yeah,
is the PG upgrade usable in case there's a data change? For an example, if there's change in the data type or the length of, I don't know.
yeah, that is yes. Hello.